Yes, sir.
Good morning to you all. I
Good
am
morning,
M.M.
sir.
Mehrotra. I am retired Chief Engineer from Military Engineer Services. I'll be talking to you on MEP services in large building projects for about an hour or so. Okay. If you have got any query, you can ask in between also, or otherwise last 10-15 minutes we'll keep time for question answers. So let us start. Firstly, why MEP is required? MEP is required because if these MEP services are not there, the building is dead. You go to Taj Mahal, this is the best wonder of the world. But if you go inside and you can't see anything, you go to best mall in the country. You go inside and there is no electricity, though there is no ventilation, there is no light, there is nothing, then you will not be able to enjoy. You will not be able to even survive. So MEP services are equally important. In a project, they consume about 20 to 25% of the cost, but their importance is much more in terms of their utility. Now, these are some services listed for you. These are the MEP's part of MEP services. If you see, there are some 20-25 in numbers. They will come as we go proceed along the presentation. Okay. First thing is some basic concept. This is always my first slide in every lecture. Some of us may be electrical engineers, some of us may not be electrical engineers, some of us may have forgotten these concepts. But what is single phase and what is three phase is important. You can see a PowerPoint on the screen. The PowerPoint on the left hand side.
Sorry, sir. Sorry to intervene you.
Yeah.
Please share your screen, sir.
Screen is not showing.
Not showing, sir.
Okay. Okay. Is it visible now?
Not yet, sir.
No.
Okay, there may be some linking problem. Just be patient. Hold on with me. The screen is open. It was earlier showing. Now it is not showing. Eh?
No, sir.
Okay.
Beginning it's not showing, sir.
स्क्रीन ये पहले आपकी स्लाइड्स को ओपन कीजिए, ऑन कीजिए, फिर उसके बाद शेयर स्क्रीन कीजिए.
इसके बाद I have opened this. Now go to share screen. Share screen. Share.
Yeah, now we can see.
You can see something. Can you see me?
Yes, you and in the screen also, no problem.
Screen also is showing. Okay, first class. So let us start now. Now, is it visible on full screen or part screen only?
Full screen is okay.
Okay. Okay, so we start with this basic concept difference between single phase and three phase. You can see this PowerPoint. On the left hand side pin is phase, on the right hand side pin is neutral, right? Now, what is phase and neutral? It is, you remember our 12th class diagram. There is a source on the left hand side. Top conductor is phase, bottom conductor is neutral. Okay, and R is the load. Now we go back up. Now this left hand side is phase, right hand side is neutral. If I put a voltmeter and if I am able to see with reference to right hand side, left hand side will show me a voltage variation like this. My voltmeter needle will go up, it will go down, it will go minus, and again come back to zero. Now suppose I have three power points like this, which are connected to different three phases R, Y, and B. So there also similar thing is happening in each of the second pin, right? Now coming to our next figure, that phase conductor and neutral conductor is carrying the same current I. In case of three phase conductor is carrying some current, and neutral current conductor is carrying a vector sum of these three currents, right? So what will happen in case these three phase currents are same, neutral current will be zero. So ideally, neutral conductor in a three-phase system is not required to carry any current. Now, what is the difference here? If there is unbalance, some current will definitely flow. This is generally in the range of 20 to 30% of the full load current. That means neutral of the single phase conductor will be of the same size as that of phase conductor, and neutral of three phase system will be half the size of the main conductor. I will also mention here about the earth conductor. What happens to earth conductor? Earth conductor as per code will be half the size of main conductor, but with minimum size 1.5 square mm. Suppose for my point wiring, I am using 1.5 square mm conductor. My earth wire will, neutral wire will also be 1.5, and earth wire will also be 1.5. So first, let us come to external electric supply. External electric supply is the basic thing which is feeding energy to our project. Now, first is from utility, there is energy coming. It comes to our transformer. This transformer is in our premises. Now, there is a something in between these two is the circuit breaker, which is in the control of supply agency and its metering equipment. So metering control is with them, not with us. Now HT supply is coming to my transformer. What will happen? Transformer will reduce the voltage to LT. It will come to sorry. First is HT supply is coming from SEB to my HT circuit breaker. Here what in figure you see is HT panel only. It's a control panel of that HT circuit breaker. Circuit breaker is outside in the yard next to the transformer. Circuit breaker is not here. So if you see this panel, there is no 11 kV or 33 kV supply here. You can consider it's an LT thing. Now what will happen from transformer? The output goes into LT panels. Then there is further distribution. Along with the distribution, there is a DG set also for providing standby supply to the building. Now this will get connected with this LT panel system somewhere. How it will be done is a different thing. We are not going into those details. There are AMF panels to do that job. Now DG set is running so when there is no electricity supply from SEB. Now come to LT side. LT, what happens? There are distribution boards. These kinds of distribution which is there in the center, you must have seen outside your house or in the buildings. Now these are having, this is a single phase distribution board, or and it is giving supply to different circuits. as we will proceed, will be more clear. Now there is something called UPS also mentioned here. Why UPS is there? Some services will require uninterrupted power supply throughout, even if there is a dislocation from supply company, right? So UPS will take care of my supply during those times, like my fire alarm system, my security system, my computer system, my uh, for that matter, my lifts also to some extent, right? Now, another window has been opened. It is called APFC panel. APFC is Automatic Power Factor Control Panel. What is there? If you remember that our circuit, inductive circuit, that causes power factor to become lagging. For neutralizing that, you need to provide some capacitors in the circuit so that factor becomes unity. Why we want this to be unity? Because then what is power that can be used is that kilowatt. You consider that sugarcane wala machine. So there, whatever work is being done is the real work. So power that is being produced to grind that sugarcane is real power. Whereas apparent power is because of circuit system, there is some time delay between voltage and current, so some power is lost. Whatever power is lost is depicted as power factor of that circuit, right? So now this is a subject in itself. Only this concept I am mentioning. Now from this distribution board, supply is going to various rooms and parts. Here it is lights which has been showed. There will be light circuit, there will be fans, there will be power points like this. Now next is schematic drawing, that SLD single line diagram. This is very important for any engineer to know. Now what happens? It's a big building. Consider a shopping mall which has got floors and wings. Now there is a dislocation in power somewhere. Suppose in third floor, east side wing, there is power dislocation. Now this diagram will tell you where my power is going, where I need to cut off the supply to make my person to work. So this is an important thing. On the right hand side, I have shown you a small depiction of single phase distribution circuit. What happens? The supply is coming from three phase, that panel which you had seen. It is being distributed to various sides, right? Now each MCB is showing one circuit. Each circuit will have certain number of points. Usually it's around 10 points in each, 7 to 10 points in each circuit. So they will take care of the right. Then next is earthing. Now earth wire you must have seen everywhere in my house, in my building, running everywhere. It is there in single phase also. It is there in three phase also. Earthing construction I'm not going in detail, but the thing is why earthing is required. Earthing is required to provide uninterrupted free flow to electricity if there is a leakage. What is leakage? Leakage means some part of our system which is not required to carry any current has become live because of touching of some wire or insulation is not working. Now if I will touch that gadget, I will immediately feel a shock. Now if there is a earth wire, that conductivity of that earth wire is better than my body, so any fault current will try to flow from that side. It will not affect me. So this is the biggest safety gadget for me. Earthing wire, as I have told, will be half the size of main conductor, with minimum size 1.5 square mm as given in the IS codes. Now, DG set, you have seen that in the previous photograph. Earthing I mentioned, there are two kinds of thing where earthing is used. One is machine, other is the supply system. When it is machine, there will be always two earthing, two for body and four earthings, two for body and two for neutral. Then there is panel. Inside panel, LT panel, which you saw in the previous slide, will not have any earthing connected to its neutral. There will be only two earthing connected to body of the panel. It is not a machine. It is only distribution. Same way, if it is transformer will also have two for body, two for neutral. Now, my DG set, earlier DG set used to be open. Now, as per government guidelines, they will be encased in a acoustic enclosure. As in case of vehicles, it is something sort of diesel vehicle only, where Bharat 4, Bharat 5, those things will also come into play. So it is important, in case of DG set, it is important that it is placed on a concrete foundation which is stable. It should not allow any vibrations. Next is ventilation. If this acoustic enclosure is kept in outside, natural airflow will take care of temperature consideration. But in case of multi-storied buildings, usually this DG set is kept in the basement, where ventilation is less. So there should be adequate ventilation in the form of exhaust fans and other things. Now, PF consideration will come in testing. Let us leave it. RECD. RECD is retrofit emission control device. As I said, in case of vehicles, pollution norms keep getting changed. Government issues new guidelines and lays down certain restrictions on the output from the effluent which is coming from the machine. Now, this restriction government will change every year or every 5 years, but these machines are produced in some factories. These factories, the machines in the factories producing these DG sets will not change overnight. So they will be given certain time, 10 year, 15 year, 25 year, when they should switch over to new kind of technology. What will happen during intervening period? We provide RECD. RECD is retrofit emission control device. You can see on the top there is a small cylindrical object which has been placed. Now, the characteristic of this will be it will absorb the particulate matter PM 2.5 with efficiency at least 70% must get trapped here without affecting the efficiency of my diesel engine, right? So there are many companies which are producing this. I am mentioning it again and again because when my building is ready, so that government authorities will come to give clearance. They will not give clearance unless until pollution control norms have been met. DG set, while we are installing a DG set, you must take care of earthing should be proper, ventilation should be proper, fuel should be easily available so that there is no airlock while providing. Fuel is your diesel, and electrical connections should be proper. Now we talked of ventilation. Ventilation, these both sides, you can see some fan kind of structure is there. So one fan is taking fresh air, other fan is removing hot gases from the system. Now this is important, that ventilation is very important so that temperature of the machine does not go very high. Now, what happens in internal electric supply? Internal electric supply is your wiring, normal wiring. This is the most neglected subject in the studies. In normal practice, it is only the electrician who knows कौन सी चीज कहाँ करना है, what is to be done, how it is to be done. Suppose my tube light, so my fan is not working, my tube light is not working, so we will immediately call the electrician and he will only come and correct. But as MEP engineers, we must know what is going wrong, where it is going wrong. Now, an MEP engineer is required to reach at site when structural reinforcement is being fixed in the at the shuttering stage itself. Why? Because fan hook will be placed in the will be connected to that reinforcement. Once cement has been set, that fan hook cannot be placed. If it is placed, it will weaken the structure. So it has to be done that way. Then there will be conduits which are required to be buried inside the concrete. They will be placed, and there will be crossings. We have to take care how my conduits are crossing. These are PVC crossing. Is there any iron sleeve required around that? Those things we are required to see. Now, fan hook. I'll give you an interesting example. While serving in Guwahati, I found the in master bedroom of the station commander a fan. There was no fan. Why there was no fan? Because the fan hook was incorrectly placed. The fan hook was about 1 feet away from the wall. When this fan hook was being provided, that laborer did not know where the downwards walls will come, so he provided fan hook as per drawing. But probably, and that MEP engineers had missed this thing, and that fan hook it was required to be made again, right? So now, conduits are required to carry wires. The conduit will not same conduit will not carry power point wire and light point wire. Power point, the points in our switch with fan light switches, there is a small power point there. There is no restriction on that. But the power points which are down below in our wiring will always be uh, passed through different conduits. Same way, in any, suppose it's a residential building, we try that only one phase is given to one house. It is possible more than one phases are given to one house. But if there is a same phase, then there is no restriction. But if there are more than one phase, definitely the conduit should be separate for each phase. Next is color coding. Color coding is important. Color coding is RYB, red, yellow, and blue. Three phases will be distributed along with this. You will see in our construction, black wire is connected to blue, blue is connected to red, and like that. So where this is let up by the electrician, whatever wire is available on that day, he will try to use that. That is number one. Number two, earthing wire will also be separate for each circuit. Each circuit means one set of wires, line, phase, and line, neutral, and earth. These three wires will run in one circuit. Now, if from one circuit, I will draw individual connections for lights, fans, and other things. So they should be independent and efficiently earthed. Means tendency of electrician is, if suppose he is there in seventh room, his wire roll has exhausted. So for next room, he will connect previous room earthing to other room. Earthing will be available when you test, but is it efficient? No, because there is a resistance available now in that earthing circuit. Now RCCB is very common. It's an important safety gadget, residual current circuit breaker, so that there you don't get any shock. Wire continuity, polarity. What is polarity? Means the switch should be placed in phase wire, not in neutral wire. Now this is a neat method of connecting of my circuits. It should not be a bunch. It should be neat. Each circuit should be separate. Now I am showing you wiring diagram of a single phase system. Here it is 8 circuits going from, like, supply is coming from outside SEB. It goes to my metering system, comes to my main switch. Now main switch is connected to this distribution board. Red is your phase, black is your neutral, and green is your earth wire. So neutral and earth wire color will always be the same, black and green. The phase wire will be different, red, yellow and blue, depending upon the phase which we are using. Now here you can see for 8 circuits, there are 8 phase wires, 8 neutral wires, and 8 earth wires also. So this is a check. Suppose you go to site and you find number of wire, any of the wire is less here. Suppose somebody has looped earth wire or neutral wire somewhere on the way while the building work is proceeding. If it is not coming to my distribution board, number of wires connected here will be less. So you have to take care of that. Next is protection of the building, fire alarm system. Fire alarm system is, the job of fire alarm system is not to fight the fire, but only to tell you that there is fire in the building. Fire in the building will have certain components, that a fire alarm system, manual call points, smoke detector, heat detector, control panel, mimic panel, and repeater panel. Now, these types of gadgets you must be seeing in the building. There is smoke detector, there is heat detector, there is manual call point. What is manual call point? Break glass in case of fire. What will happen? It has a switch which is spring loaded switch, which is in pressed condition. The moment you break the glass, it gives supply to the hooter, and immediately alarm is raised. Next is smoke detector and heat detector. Heat detector will activate if the temperature of the surrounding near the detector is anywhere between 65 to 80 centigrade. Below that, that means there is no fire or fire is controllable. But when the fire has spread, the temperature in that vicinity will reach to that levels. Then your heat detector will operate and set supply to my output devices. Output devices I will come. Next is smoke detector. What is smoke detector? Smoke detector works on optical principle. If there is smoke, light will not be able to pass correctly. So when there is a disruption in that light beam, this smoke detector activates. Now these things will give signal to my fire alarm control panel. fire alarm control panel will give signal to some siren or hooter. So they will be placed somewhere in prominent positions. Now, this figure also shows control panel is given signal from input devices. Control panel gives output to output devices. Output devices are my siren and hooter. Normally, fire alarm system is not required to operate any firefighting system. Firefighting is different. Fire alarm is different. Fire alarm is totally electric, like internal electrification, something like that. Now you have seen certain components: manual call points, smoke detectors, heat detector, control panel, mimic panel, repeater panel. What is control panel? Control panel is obvious. The detectors will detect some occurrence of fire. They will give message to control panel. Now, what is mimic panel? Now, there is a wiring sort of a thing. System will not know where the fire is. So, mimic panel will show what is your floor plan and which detector is activated at which location. Repeater panel will be provided in your main security room. Mimic panel will be at the floor or at the building entrance, whereas repeater panel will be with the security people near the gate or some security control wherever it is there. Now, this is this how detectors are provided. Detectors are provided like we do internal electrification. We find out how many lights and fans are required in a room. Same way, the complete area is divided into zones where, depending upon the capacity of detector, number of detectors will come. Each detector, there is a supply coming to my control panel. Control panel, mimic panel, repeater panel, I have already told. So mimic panel is giving visual representation of the building layout and location of the fire detection devices. So my LED will tell me where the fault is. Nowadays, mimic panel, repeater panel, these are not required because these are computer displays have come. So now that at one location, computer display will tell me where my fire is. So these things I have already discussed. This is the basic scheme how this thing works. Means there are detectors which will give signal to control panel. Control panel is also getting electric power supply. This is normally LT supply 120 volt or 240 volt. Then there hooters and sound. It will activate hooters and sounders, and there are communicating devices which are at the manned location, repeater panel or computer screen. Now, air conditioning, ventilation, I am not going to into the details of ventilation like AC plant, because that itself is a science in itself. You need at least 1 week course for knowing what is there in a central AC system. But I will mention what is there in a building project. Except for central AC, I'll discuss other points. Window AC and split AC. Window AC and split AC, we are all aware, but we have to take care. These must be at least 4 star, 4 star or 5 star, because Griha rating norms given by the government have to be followed. Now, one small precaution I am mentioning here: in case of split AC, supply is coming from my distribution board, going into the outside unit where my compressor main power consuming device is there. That is my compressor. From there, supply will come to my inside unit, that fan and evaporator unit, that is called. So this supply will be disconnected through a minimum 2 square conductor, because normally in wiring we are using 1.5 square The electrician may miss it and connect it with the same. It should be minimum 2.5 square for any air conditioner, and it should not have any joint from outside to inside. Now we come to ventilation. This is parking lot of a building. It must be somewhere in the underground area. Now, underground area will need there are no windows which will take foul air outside. So we have to provide this a ducting arrangement like this. Now you can see on the in the right hand figure, these ducts have come right near the floor level. So there will be exhaust from these vehicles, which will be sucked in by this ducting. There will be fans. There will be different type of fans which will be there. Now this ducting network will ensure that that air is taken away from this. Now what kind of fans are used? These are three kinds of fans usually used in this. Axial fan normally we see in our desert coolers and other things. It is similar fan but slightly higher power. Next is jet fan. Jet fan you must have seen in parking areas of shopping mall and in the tunnels that where the traffic tunnels are there. So this is a neat arrangement. This also this also take care of ventilation requirement in large area without having lot of physical things. Next is this centrifugal fans. Centrifugal fans is similar to one which we have in our kitchen chimney. So this the air from the ground is being trapped here, and through this is a centrifugal fan, it is taken away into outside environment. Next is lift. Now lift is will conform to certain IS. IS is mentioned here. You have seen these lifts are provided with a machine room on the top. There is a huge well on which your machine moves. So there is a machine room which is provided on the top. Now machine room less lifts are coming where these facilities are placed on the top of the passenger car itself. Now what will happen, how this machine is moving through iron ropes. Iron ropes similar to the pulley which we used for lifting water from the wells. So there's a reason for telling this pulley kind of arrangement. I'll come to that. There are three kinds of lifts which we normally encounter: is passenger lift, goods lift, and dump waiter. Dumb waiter, I hope you are aware. Anybody not knowing dumb waiter? Dumb waiters are used in hospitals and in shops and restaurants. They do not carry a person. They carry only the luggage and certain objects. Dumb waiter is a small lift, but here the person is not moving in these lifts. Generally, what is the safe limit of speed of lift? 1 to 2 meter per second. If the building is tall, then it may go up to 2.5 meter per second. Suppose the building is 100 story or more, then there are other arrangements to take care of the effect of G, so that the person inside the lift does not feel the thrust of gravitation. Fire lift. Fire lift is important. The moment there is a fire, my fire alarm system has detected some fire. So immediately my supply system to lifts will be switched off. No person in multi-storied building should ever use lift in case of fire. There will be only one lift which will be operational. It is known to firemen which will be entering the building from outside. So all other lifts will be made non-functional. Fire lift will be used by the firemen to reach the, because they know where the fire is, whether this fire lift is safe to be used or not. There will be an intercom inside the lift. What will happen inside the lift? There is an intercom. Suppose the lift gets, because suppose there is a supply dislocation and lift has stopped. So intercom is only lifeline available to person trapped inside the lift. So intercom is communicating with the guard sitting in the main building entrance or somewhere in the common area. There is something called automatic rescue device. As I mentioned, lifts move through.
Please mute your mic. Unnecessary person. Please mute your mic.
I request all the participants to come in muted mode. Okay. Your voice is coming here. It is disturbing me. Please mute all your mics.
I have sent many messages
Now, what is
for
automatic
Mr.
rescue
Channa.
device? Automatic
Please
rescue
mute
device
yourself.
is to take care of your lift. Suppose there is a power
Pick my
dislocation
call.
while somebody is using this lift. If power dislocation is there, then somehow the person should be able to come out. What will happen? Like a well pulley. Suppose it's a 8-passenger lift. So same amount of weight will be provided, counterweight will be provided on one side of the rope, and other side of the rope is connected to the car. So the load
Lalma
ideally,
Chona, please mute your mic. Lalma Chona, please mute your mic.
Is
so
it
what will
possible
happen
to
is,
remove from the meeting because we are getting disturbance? Yeah.
so what will happen if there is a supply dislocation, this lift will stop. When there is no supply, that brake is permanently applied. When there is electric supply is available, that time brake is released and lift moves. Now, suppose there is a person who is trapped inside the lift. He sends a signal through intercom to the security person, so that I am trapped here, please help me. So what will happen during this time? This automatic rescue device is provided supply with a battery system. It will activate and move the lift to the nearest available landing, depending upon the load in the car. Suppose there is passenger load is more than what is there in the counterweight, the car will move downwards. Suppose there is only 1 or 2% trapped, so the car will move upwards. So what will happen? It is moving by gravity during this time. When for a short time, ARD has released the brake for a short time, and the moment it matches the level of landing, it will immediately ensure that brake is applied. Now the car will not move. The security person will come, and from outside it will open the door and take the trapped person outside. So this CRT is important. Every lift, this safety precaution is there. It is provided. Now, floor signboard. Floor signboards are important. When buildings are being constructed, normally as my door of my car opens, there is no, I do not know which floor I am in. Depending upon the call, the lift will stop. It may not be the desired floor location. So what will happen? So the I will get confused. I may not come out at my intended floor. There has to be a signboard which is right in front of lift. Next is lightning protection. Lightning protection, as you know, lightning takes place in the sky where cumulonimbus cloud produces lot of energy which falls on the ground, and it will have the tendency to catch the object which is highest. Now this is a figure of my building. You can see some features of the building. So there will be provided on the top. Can you please switch off your mics? Participants, please switch off your mics if you are not. If you got any question, ask me. Otherwise, switch off your mic. Then lightning current will come and caught through these finials, vertical finials which are there on the top. They will be taken into ground through these conductors. Now this is ground level. That dashed line is ground level. So these conductors are connected below ground, so that they provide the best possible way to the lightning current. Now next comes, these lightning takes place, it is intercepted by these finials, it is taken to ground. And now there's one thing I have written here as potential equalization. This is a different application, not connected to lightning at all. Now what will happen? Suppose this is the finial on the top. It provides a zone of protection. The zone of protection is certain conical angle. Suppose there is a finial in the center, it will provide protection in this zone. Suppose the finial is on the edge, it provides protection on the sides. Certain small buildings in the vicinity will automatically get protected, right? So this is importance of finials. Finials are providing all along the periphery, and suppose this gap has to be maximum 9 meters. Suppose this width is more than 9 meter, then there will be row in the center also. So there each finial will have minimum 9 meter with reference to next finial. I come to water supply. What happens to my water supply? Water supply, there is not too much of engineering how it is being distributed. I am not going into plumbing part. Plumbing will have distribution, airlock arrangements and other things. I'm not going to that plumbing part. But how my water supply is coming from public health engineering department, it is going into my water tank. Suppose I use it daily, it will get consumed, water will not become stale. But there is a fire tank also. Fire tank will take care of any
sorry sir,
fire.
your screen is not visible sir right now.
Okay, hold on. Is it visible now?
No, sir.
Yes, it is visible.
It is visible now?
No
Yes,
sir.
Yes.
Means if it is visible to some participants and not to some, then the problem is somewhere at your end, not at my end. If it is not visible, it will not be visible to anybody. What I hear, some are able to see, some are not able to see. So kindly check your connection. Now, where shall I continue? Yes or not?
Uh, at present, this is not visible. Earlier, it was visible.
At present, it is not visible. Okay.
Now not visible to anybody.
Not visible to anybody.
Earlier it was partial visible, not visible to anybody.
So there is some issue with the connectivity.
Maybe you can stop share and do it again.
I did that. I tried to do that, but it didn't help. I'll do it again.
Yeah, because it was visible to me, but now it is not.
I'm trying to share it again.
Yes, it's now clear. Yes, it's visible.
Now clear?
Yeah.
Okay, so some connectivity issue from my end also.
Okay. Thanks.
Shall I continue?
Please,
Yes, it is visible.
Yes, sir.
Please.
Yeah.
Yes, sir. Yes, sir. Now
Now,
it is visible.
fire tank is important safety precaution in a building. This fire tank should always be full. In case of fire, it will be used. Its water will be used to the full capacity. But I have to make sure that water in the fire tank does not become stale. After 1 week, this tank with water will start stinking. So what I do, I bring my inlet connection into this fire tank. Overflow of fire tank will go to my drinking water side. So what will happen? Drinking water side is being consumed every day, but every supply time water will come and it will ensure that water in the fire tank also remains fresh and doesn't stink. With this background, I come to firefighting. What will happen in firefighting? This IS code has got tables depending upon the height of the building. It will tell you what kind of firefighting arrangements are required, right? So these firefighting arrangements are needed only for the buildings which are 15-meter high, in 15-meter height or above. Below that, there is no requirement, or that is why we don't see any firefighting arrangement in our single story, double story, up to 4-storied. You will not find any firefighting arrangement is there because the building height is less than 15 meter. But suppose it's a public area, public utility, some hospital or some shopping mall is there. There the height, where the height is not 15 meter, still I will provide these firefighting arrangements over there. There are different kinds of fire given out by different types of material. My garbage may catch fire, some flammable liquid may catch fire, some electrical system may catch fire, some wood or something like that, or some combustible material is there. So what happens? Firefighting is a very important feature of any building. I have seen it. If there is a fire, it spreads very fast. It doesn't give you much time. It spreads so fast that the person trying to fight will have to run away to save his or her life. So these things are important. Now, for different type of fires, we need fire extinguishers of different kind. Water fire extinguisher will not work for electrical fire. So these A, B, C, other kinds of fire which are there. Now foam will be used for electrical small electrical fires. Wet chemical will not be used for electrical fires, but suppose there is a small storeroom which has caught fire. So that can be then done away with using water, air, or wet chemical. So this is an electrical panel room where it will produce lot of carbon dioxide. What happens? For fire to sustain, you need oxygen. If you provide lot of carbon dioxide, it will deplete the area of oxygen and the fire will extinguish. So this is the method by which electrical fires are fought. Now these are two figures which you can see: water sprinklers and deluge fire suppression. What is water sprinkler? You must have seen it is there in hospitals, it is there in libraries, it is there in other common areas of the shopping malls. These water sprinklers will get activated when there is pressurized water there in these pipes. Then this will so where it will be used, depending upon the signal given by fire alarm system, it will cover certain small area. If there is a fire, it only that area will get water from water sprinklers, others will not operate. Now, what is deluge fire suppression? Deluge fire suppression does not get any signal from my fire alarm system. It is outside India. The system in multi-storied building is there's a garbage chute where the individual occupant throws in their garbage from the top floors. That is why you are seeing color coding of different all this thing. Now there is a room at ground floor or underground level where it is all garbage is being collected. There may be a fire there. Now nobody will be able. Now if there is a fire, that there is a garbage there, it will catch fire and that will spread very fast. So there is a need to fight that fire on topmost urgency. So what will happen? So this deluge fire suppression system will operate instantaneously with reference to that from activated from the fire. It will not wait for the signal to come fire alarm system. Now what is there in my firefighting pump house? Firefighting pump house will always have three pumps. One is electric driven pump, other is diesel driven pump, and third is a jockey pump. Now electric driven pump is normally used for firefighting, but it may happen when there is fire, power supply to the building has gone. So if this is not there, it will wait for certain time, and after certain time it will operate. So it will ensure that water pressure of about 5 kg per centimeter square is maintained in the fire line. What is the work of this jockey pump? Jockey pump will have a pressure sensing device. The moment what pressure is below 5, it will operate and maintain the pressure. Pressure may fall because of certain minor leakages and other things. So it will ensure if there is a fire, anybody wants to fight the fire, then water is available at full pressure. So this water is coming to these water points. They will for fighting fire. We need roles like this. So each fire point will have two roles like this. Each roll is 15-meter in length, 15-meter in length. So architects are given this restriction that fire point will be placed where the output of 15, not more than 15-meter distance is there for the escape route. So this is what we see in our floors. We see this So there is a nozzle which will get connected to this. So when this is connected and you can fight fire. When this is carrying high pressure water, this uh, tube will become hard like rock. So it cannot be bent like our normal flexible pipe which we use for gardening. So it will be purely straight. So that is there. Next is dry riser and wet riser, which the table which I had shown you earlier, we had mentioned dry riser and wet riser. What is dry riser and what is wet riser? Dry riser, wet riser is where this firefighting line will always have pressurized water. While in case of dry riser, it will not have pressurized water. It may have some connection from the terrace tank so that there is no airlock there. But suppose there is a fire, then this fire tender will come. It will get connected to this header. This will provide water at pressure at different floors. So the firefighter will come and fight the fire. In case of wet riser, this water is available right here. So without waiting for the fire tender, fireman can come and fight the fire. So this is the difference between dry riser and wet riser. So these are too technical in nature. With that, I am not. I want to tell you why and where these facilities are used. Next, I want to introduce you to a word called BIM. BIM is Building Information Module. What happens when the building is being made by the designers and architects? They use AutoCAD system. Now, AutoCAD system will have drawings which can be depicted on the piece of paper. Means what we generally see, whether it is plan or elevation, it is always a two-dimensional figure. Now I want to see when my building will be made whether I'll be able to take my services unhindered or not, or will there be any clash. So for that, there is a software available which is called BIM. It will ensure that the structures, how you see the construction, you see a concrete cage is being erected, right? Now once concrete is set, it cannot be changed. So we have our BIM which tells us on a computer screen in advance, this is the place my air conditioning line should pass, this is the place my electrical line should pass, and other things like that. So that is why I have mentioned this. BIM is an important tool for MEP engineers. The civil engineers cannot survive without this, but MEP engineers also, for them also, this is equally important. This BIM will be there till eternity. Means suppose something has happened to the building after 20 years of construction, somewhere some crack is being observed. So that these BIM will tell me where how my reinforcement has gone, and that then I can check the building and take corrective actions. Next is building management system. Building management system is where with different services, like I have got security system, I have got fire alarm system, I have got public address system, I have got lifts, I have got air conditioning systems. So all these things are connected to a building management system. Earlier, each of these things which I mentioned were having their own software Like uh, air conditioning plant was being looked after by their own system. Now that same software has been enlarged to cover all kinds of facilities which are provided in the building, so that you can communicate. So during use of that building, this BMS becomes very important. Now, these are the items which are covered by that BMS: heating, ventilation, air conditioning, lighting control, fire alarm, firefighting, security, CCTV, lift, pumping, water tanks level, irrigation system, electric meters, water leak detection system, splits units. Then there are variable frequency drive. Variable frequency drive is basically part of your air conditioning system. So things like that. Now, how this building management system is connected. As I said, primarily this BMS was created for HVAC. So HVAC is one part. Rest other are also connected to this building network. Then they come to BMS. So what that computer system you are seeing is actually your BMS. AC system is directly connected to this BMS. Rest others are connected to a building network which comes to my BMS. So this is the right way of connecting building management system. Now building management system will have some microprocessor based control where it can provide. There is a word called Internet of Things, IoT. IoT is where you have actuators and sensors. They collect in status of the facility and provide an electrical signal, be it a compressor in air conditioning plant, be it fire alarm system, or electrical circuit breaker, status of electric circuit breaker, or a computer system. Now, all these signals are getting connected to my BMS. BMS has got a microprocessor in the heart of it. So, it will make sure that your communication with these facilities is complete. Now, these are the facilities which get connected. Each thing is a science in itself, so there is no time to cover all these facilities. But the thing is, all these features are connected to a common system through building management system. When there is a fault in any of these, my system is useful. I immediately come and see in the screen which part of my system is faulty and not working. So I will attend to those things. Other than these, there is with this I am coming to nearly end of my discussion. If you have got any questions, I'll have 10-15 minutes for that. In building, we also have PA system, cable TV system, access control system. Now, all these things are low voltage electric supply only, which will have wiring arrangement same as we had done point wiring for our light, fan and power circuits. Here only the type of conductor and where it is passing through is different. Otherwise, fundamentally, they are the same. Output, in case of light point, there is a output given there. In case of like cable TV system, there is a small point which is coming on your board where you can connect your cable TV. With this, I finish my talk. If you have got any query on this, whatever I discussed, you feel free to talk to me. Any questions? I have tried to cover the fundamentals. I have not tried to complicate the things, because when you go into actual science and engineering, it becomes very complicated. So I have tried to keep my discussion simplest possible. If you have got any query, you can unmute your mic and you can always ask. Otherwise, yeah.
Yeah, thank you very much, sir, for giving me a very brief introduction of all the parts. Actually, you have covered almost everything which is required in MP. Can you please suggest that if you want to go deep down in all these parts, can we refer further some books? If you suggest some books so that we can go deep down in these things.
Books, the best book today is internet. What you do, I also do. After I have put in about 37 years of service, even today, if my books have long been kept in the box or not available to me, I open my internet, I type my query, and it is known. Otherwise, whatever we have studied, those books are best. They will when I study, I go through the Google, some queries come into my mind. So if on the basics it is there, you go to the book. Otherwise, best is you search Google. YouTube gives lot of good practical videos. You type your queries, you get everything. Like, I'll tell you an example. When there was no YouTube, I today I can handle it easily. I'm talking of 1981. In my first year of my service, I had joined electrical engineering. So when I in one of my breaks, I came home. There was my tube light was not working in my study room. So I went to my father. Please call an electrician, because that time there was nothing was there. So please call an electrician to rectify my tube lights. So my father immediately told that you are an electrical engineer. You are asking me to call an electrician. So then I went to the market, saw from the books which are which circuit is used for activating that tube light. We become theoretical engineers, we are not practical engineers. Then afterwards my problem was resolved. I studied the circuit. I found the choke of my tube light was not working. I brought a choke, connected it, and my tube light started working again. So that is one part. But the thing is, we may not be doing that work, but we must be aware what my electrician, plumber, or people like that, they are doing, because our mental level is much better than theirs. So for your present, your books of your engineering or whatever you have studied are good enough, plus Google and YouTube, they are very handy. Anything else?
Sir, good morning. I have a small question.
Yeah.
I just want to understand about two things. First is dry type fire suppression system required for hub room, UPS, and data rooms. And
Yeah.
second thing about selection or combination of air cooled and water cooled chillers in tandem with the water balancing chart or the peak water demand.
I'll come to your second question later. First is, you suppose it's a data room. Data room, there is a fire, right? So it will be treated as electrical fire. So whatever is applicable in case of electrical fire, that will be used here. In certain cases, some gases are available to protect that data room. Data room, suppose it's a communication system of uh, data room of national importance. So there is no time. So what happens if there is fire? Immediately people will rush outside. Then that room gets sealed, and some gases are released, which will deplete the area of oxygen, and the fire is put out. But that is costly, not provided as a normal. I have seen in these navy ships are there in the compartments. It is there. Sometimes they use it for their strategically important signal centers also. And next, you asked about that's what was the second question?
Optimistic uses of water cooled chiller and air cooled chiller, or a combination of both these.
Okay, water cooled and air cooled chillers, like these are dependent upon the capacity which we use. Suppose my requirement of air conditioning at one place is more than 7.5 ton. So I will not provide any window based air conditioning system over there, right? Now up to 15 ton air cooled air conditioning system will be good enough. Beyond that, it becomes uneconomical. Then I'll have water cooled air conditioning system, central air conditioning plants. So things like, suppose my requirement is 15 ton, but at any point of time more than 7.58 ton is not required. So my air cooled system will provide me good enough. Beyond that, it becomes un inefficient, right? Anything else?
Okay. Thanks a lot, sir.
Thank you so much. Then I'll take leave. Probably we'll meet sometime in future. If you have got any queries, you can share with ECI. I will try to reply those queries to ECI so that if any doubt is there, you can resolve. With this, I will now stop sharing my presentation. I'll leave the meeting now. See you in future.
Thank you, sir. Thank you very
I'm
much.
audible?
Thank you, sir. Thank you.
Thank you very much.
Thank
Thank you
you.
very much. It
Thank
was
you,
a
sir.
lovely,
Thanks a lot.
discussion.
Thank
It was a pleasure interacting with you. It is always good to hear from people something about our job which we normally. I have not told anything which is highly technical in nature. It is only the practical points which I have tried to highlight, which you should be taken care of. Okay, thank you, gentlemen.
Thank you, sir.
Thank you, sir. Thank you very much.
Okay, Mr. Yograj, I will leave the meeting. आपका next session must be on the way, right?
Okay, right, sir.
Okay,
Thank
thank
you,
you.
sir. Thank you. Thank you. Thank you to our respected speaker for the insightful session, and thank you to our wonderful audience for your time and attention, please. Thank you, everyone.
Thank you, Yograji. Thank you very much.